Okay, so as I was saying, guys, it is important that we communicate, and it's important that you have that you developed. Okay, you don't have to have it yet. That you develop an ability to analyze. Okay, it's going to be very important. So as we progress through the course, we're going to begin with the basics of manual testing. We're going to begin talking about why we do manual testing. Why is it important? How does it play a role um, in the development process or in the life cycle of developing software? Okay. So from here on out, we're going to begin with some light introduction into what manual testing is going to be. Okay, I'm going to begin sharing my screen, and I'm going to ask you guys to please confirm if you are able to see my screen. And here's the question: are you guys able to see my screen?
Yes.
Yeah.
Yes.
Excellent. Oh, you guys sound lively. I love it. Very good. Okay. So this course, as I mentioned before, this is an introduction to manual testing. Um, Here we'll be exploring um, how a manual tester, just a quick question, can you guys still see?
Yes.
Yes.
Oh, perfect, okay. Since I put it in uh, big screen, I want to make sure. So as I was saying, we're going to start introducing manual testing, how manual testing is used, why manual testing is important. Now, throughout today, you're going to be seeing a couple of terms, and you're going to be paying attention to something very important, um, which we're going to be talking a lot today, and that is called SDLC. And give me 1 second, please. So this word right here that I just mentioned, SDLC, this is going to be very important. This is going to be your bread and butter of your manual testing course. So as we talked about it, as we talk about it, as we progress through it, I would like you guys to take as many notes as you can, pay as close attention as you can, because eventually this is what will help you in any situation. This is going to be the basics, and whenever we are in any tough situation, what helps us is going back to the basics. Okay, now manual testing. If any of you have played a video game, or if any of you have I don't know, but purchased clothes, or any sort of toy, or machine, at some point that item went through a phase of testing. Okay, that material was testing to make sure that it would reach the customer, end user in this case. It will reach the end user's hands in good shape. Okay, with minimal problems, with minimal defects. Okay, so it's important to know that anything and everything that we use today, whatever we have in our homes, whatever you have on your person, whatever you have on your phone, everything was tested. Without testing, things would not work the same way. Okay, we will have a lot of issues. We still do have some issues from time to time, of course, uh, but it limits the issues that you receive your end product with. Now think about your phones, for example. All your phones, all the applications that you use, where you open your phone, that um, to play a mobile game or to use the calculator, to use the browser or Google, any of these things, any of these applications, this these applications went through a process. That process, once again, is the software development life cycle, or SDLC. Okay, so keep in mind that testing is a very important role, and no matter where you go, no matter what company exists, they will always require testers, be it manual testers or automation testers. Now, forget about the word automation testers. This is something that we will explore further in the course as we move on. Now, what makes, why don't we, let's go a little bit over what the contents of the course is going to be. Again, the overview, which we were going over just a moment, and course objectives. We're going to talk a little bit about prerequisite and target audience. All right. And why don't we talk about prerequisite and target audience? I mentioned to you early on about being able to analyze. Okay. Obviously, common sense in anything in life is expected and is useful, but analysis, being able to analyze things, process things. Okay. If you see, for example, this slide right here that you're seeing right now, and I ask you to tell me, how can you make this better, or how can you make this, how can you improve it? You know, you're gonna look at it, and your process, your analysis processing power, let's call it, it's going to be able to come up with different ideas. Okay, so in projects, this is exactly what you will be doing on a daily basis, on a regular basis. Looking at a requirement and then talking and then thinking through it, thinking how you can make it better, how you can break it. Okay, and we're gonna get into that, into the mindset a little more. Okay, but prerequisites, think about this. You need to have some basic knowledge of computers. Okay, you don't have to be uh, uh, you don't have to be an expert, but you need to have a basic knowledge of computer, the way so the keyboard works, the way really the computer itself works, you know, when you right click at what, you know, the stuff that you see. So basic knowledge is important for this course in order for you to really progress along. Okay, the target audience, again, target audience in this case, I think, is very subjective. I think it relates more to people who really have a passion to break things. This is the way I think about it, because in essence, always remember this: a tester always wants to break things. Okay, if we compare a tester against our polar opposite, it will be a developer. Because what the developers do, they create, right? They write code to create something, to create a software. The tester, on the other hand, he's looking at every possible way to make sure that that creation can be broken. Now, if you succeed in doing that, you're an amazing tester. Okay, and that's the goal of that. So when we go back to the context of target audience, really anybody can be a tester, but not everyone can be a great tester. Okay, let's move on. We're going to be seeing again, as I mentioned before, the process of SDLC, the SDLC process, or software development lifecycle. We're going to see this in more detail. This is going to be, as I mentioned before, your bread and butter of this course of manual testing. And also, you're going to be really seeing this throughout anything, your career, you know, as you become successful in becoming a tester, becoming an automation tester, as a manual tester, doesn't matter. This is exactly what you're going to go through every single time. Okay, this is a process that will continue to exist, will continue to expand. Okay. Now, the software development life cycle has a couple of subtopics in between it, and I'm gonna take a look at this. Sorry for being late. All right, Sarwat, you're not too bad, as we're still talking about um, the course content. So
Okay, that's great.
yeah, so sit belt on and strap on. We're gonna take off soon too. All right, so the SDLC, as I mentioned, software development life cycle, it has a couple of sub material within it. Okay, and that sub material is about process. The process about how does it work, right? Process involves mechanism. Process involves thinking. Process involves connecting, right? So we're gonna talk about the process of the SDLC. You know how the SDLC comes to be the important mindset that it is. And then it moves on to the phases. So software development lifecycle has phases in it. Okay, just like anything, just like you have a phase when you wake up, right? So say you wake up, um, and when you wake up, you go to the bathroom, you do your necessities, you make breakfast. But obviously, before that, we snooze the alarm like 5 times, right? Because we don't want to wake up that early. So it's a process, right? Your wake up routine is a process. You're going to bed is a process. You're going to work is a process. Everything is a process. And the same, and it has phases. And the same thing with the SDLC. The SDLC also has phases, which we will go through. And each of those phases are very important, and they all play a very important role in how a software is developed. Okay, and within those phases, you will also find um, one that is very particular to what we are trying to make you accomplish in this course. Okay, a modern infographic. This is just something that we're going to be seeing, so you can have just a little more visual of how the software development lifecycle process in itself works. And we're going to be doing a little bit. This is going to be more of an overview of everything that we've seen between the phases and the process of it. The SDLC methodologies. This will delve more um, into the methodologies that are used in the process of software development lifecycle, right? So, and we're going to talk a little more about methodologies as we approach that area. But it's a couple of methodologies, and obviously not all companies use the same. There's actually one that's very um, hot right now. Is that hot topic? Is the next big thing, as we say. So but we're going to be talking about some of those and which companies or which projects in per se would benefit from the different methodologies that exist. We're going to be also discussing about the levels of or types of testing that exist. There are two major sub points here. And the ones that we can see are the functional testing and non-functional testing. Okay, so this involves a lot of different things. For example, in functional testing, we're going to find ourselves doing more white box testing, and don't worry about the terminologies that I'm using right now. You will see this further down the course. And in non-functional testing, you're going to be seeing more of a black box testing, but once again, don't pay too much attention about what that means because we're not going to be doing anything with it right now. However, you will see and learn about that as we progress through the course. Now, the bread and butter of your bread and butter. So why don't we call this the jam? Okay, we're going to call this jam. Okay, of the SDLC, which pertains mostly to what you guys are going to become here, is the SDLC, the software testing life cycle. Okay, this in itself is a very important process This is exactly what you will be doing within the software development lifecycle. Okay, and this is going to be very important for you to grasp, and we're going to be going over each of these subpoints here very in very detail. Now, we won't be seeing this today, of course. We're not going to be seeing all of this today because these are expanded topics, and we want to make sure that you will be able to grasp the idea, and that you will be able to be one with this methodologies. Okay, and then we're going to be talking about tools thereafter. Like once again, as we progress through the course, we're going to be talking about what tools you use to do manual testing, right? Like test management tools like Jira, HP ALM. Okay, and once again, don't worry about those terms, as they do not pose any interest or importance in this phase of the course. So, overview. Testing is a critical phase of software development lifecycle. Manual testing is the process in which the defects are identified, isolated, subjected for justification, and ensured that the product is defect-free. In order to produce quality product, it requires, however, necessary knowledge, in which we will go over and cover in this course. Once again, let's break this down little by little. We're here seeing once again this software development life cycle, okay? But more than that, what we're saying is that in manual testing, there is a process. And in that process, what we do is we try to identify, okay? It's important, this word, identify. Because without this, that means we're not really doing much. And what are we identifying? We're identifying defects. Defects, can somebody tell me what defect means?
Like bugs,
Okay, what bugs? Like
any issues or any error?
That's
Yeah,
correct,
error.
exactly. In software, defects or bugs are what we call, say, not per se errors, but it's what we call a problem in the functionality. Okay, so let's take an example. Let's take an example. So you are on your calculator. Let's go with the calculator. It's always the easiest one. So let's go with your calculator, and all of a sudden you're trying to add 2 plus 2. But every time you add a number, every time you click, you tap on 2, it just so happens that instead of just adding 1, it's always adding the number 3. Now, would that be a defect in the program?
Yes.
That's right. It would be a defect in the program because it is not performing as it is expected. So a program, software, entity, anything is always supposed to work as expected. And the only way that we can make that we can produce a product, a high quality, okay, a quality product, is by identifying and isolating those defects. Okay, so this is really your purpose as a tester. Anybody has any questions there?
No.
Perfect. Is it the same person talking, or?
Yes.
Okay,
So
well,
far.
yeah, it's just been you. Come on. All right. Course objective and target audience. To understand what is testing, we just talk about that, right? Software development model, architectures of software development, types of testing, test plan design and creation, test case creation. Okay, so the purpose really of this of this course is really for you to understand by the end of this course, or by the end at least of the manual testing phase, you will know what testing is, why you need to do testing, why is it so important. Okay. At the end of this module of manual testing, you will know how the software development model works, the architectures of the software development model, the types of testing that you will see, that you will use, that you will have to incorporate in your work as you join a team. Okay. A test plan design and creation. Now, test planning. So test planning is an important tool for any tester, but at the same time, it's also useful for your stakeholders. Now, stakeholders, that's a word here that I haven't said yet. So now, what is a stakeholder? A stakeholder is anybody that really has any implication with the software or product that you are working on, that you're developing. Okay. Most of these folks will be your development team, the business owners. Okay, those are normally the stakeholders. But this test plan here is design and its creation. This test plan, it's going to help you visualize to your stakeholders what your test or what you're testing it's going to cover. Okay, so there's another important word there, coverage. Okay, we need to think a lot about coverage, because coverage in itself is really how we find if we are actually finding the defects, or any possible defects that exist within it. So this test plan is going to be very important. So we're going to go through a phase where we're going to be working through a test plan. We're going to be teaching the process of how to create one, and how and when do you have to use it. Okay. And then test case creation. Once again, test case creation, this is also part of the test plan in itself. Because the test plan, once again, you're already discussing what the test coverage should be, right? So if you already know the test coverage, then your next step is to create test cases, okay, to encompass that coverage. Now, the reason you need to understand this is so that you can learn the features of the software development models. Okay, major concepts of testing methodologies, different approach to testing, test plan execution, and defect tracking and logging. Okay, so these things that you will be learning, they will complement that understanding that you already have. So when we're talking about features of software development models, what we're essentially looking is back to your understanding of what is the software development model and the architecture of software development model. Now, this all includes your initial understanding of software development lifecycle, because this all happens in the very early stages of the software development lifecycle. And we'll be seeing more of that as we progress through the course. Types of testing we talked about. And so the different approach to testing is how your types of testing comes into play. The reason why is because knowing how many or which types of testing exist and knowing it in detail will allow you to understand which approach you need to take when, for example, going back to the your understanding of the software development model, you're going to be able to then say, okay, based on this requirement here that I have, this is the level of testing that I think we need to work on, right? So if you have a, let's go back to that calculator. So if you have that calculator, for example, then you say, oh, we're introducing a new functionality, and that functionality is going to be that for every number that you double tap is going to add 5 numbers, right? So say if I double tap 1, it needs to add 5 ones, right? So if that is my functionality, so me as a tester, I'm going to start thinking, okay, what kind of testing should I do on this thing? Should I do some, functional testing? Let me think about white box testing on it. Should I have to do any black box testing? So black box testing again goes back to a little into the database. So does it really matter? No. So that's something that you discard. So you really don't have to do any of that. Okay, so you're going to be really looking at the overview, at the functionality of it. So maybe some system testing if it's connected to through any upstream or downstream applications, right? So it all gets connected. So ultimately, knowing which types of testing exist allows you to be more proficient into identifying which approach you need to take to testing. The test plan execution, of course, is very relatable to the test plan design and creation. And how you execute it, of course, is by making those test case creation. And once again, the test plan, once again, does play a very important role in how you present your testing and really in how you understand the level of testing that needs to be performed. Defect tracking and logging, that only comes after you do your test cases. So your test case creation has to be targeted at what functionalities you can cover where you think is the highest possibility of defects. Now let's talk about that for a few here. The highest possibility of defects. Now, here's a question to the group, and I would like somebody else to answer this. How much testing can you do?
As much as until it performs without any mistakes.
Okay, very good. But does that mean that you can does that mean that so like there's an infinite possibility of maybe of testing, right?
Yeah.
So do you do every single possible scenario for testing?
You do everything that you can think of, and then you let the developers know what you've done, and then they'll see if there's like if they can think of maybe a scenario from the top of their head at that moment.
Okay, that's fair. That's fair, and that's very true. However, as a tester, what you also need to think of is that there are some tests which are out of scope, okay, or tests that really don't have priority. You only have certain time to perform testing. And within that time, you need to figure out which level of testing you need to perform. You can do an infinite number of test cases because you can think of so many, right? The developer can also help you and think of so many. However, you cannot execute every single one of them. Go ahead.
Yeah, we can test what is in the requirements. No, I mean, which is in the scope, right?
Yes, just like someone said on the chat as well. So according to requirements, you can do testing. However, remember, there's one thing that is important as a tester as well. Once you are in a project, and you got the requirements as a tester, and this is very important that I will tell you right now, and I hope that you take it with you wherever you go. As a tester, you always have the mindset of the end user. Always, you must always think like an end user. Because if you only think about as part of a team, if you only think about as part of that's right. So and my conversation actually is leading to that. So very good. Sarwat, did I say that right?
Yeah,
So
you're right. Thank you.
awesome. So we can also suggest a new requirement if required. This is very important because that's exactly what that leads to, right? So we are reading our requirements, and now we're going to create test cases based on that requirement. However, thinking like an end user, I'm going to say, so say my requirement only says, you know, the functionality should be that if you double tap a number, the number should propagate 5 times its count. So I'm going to start testing for, okay, so I'm just going to double tap it, right? I'm going to double tap it and see if it propagates. Okay, the output propagates to 5. Now, the requirement can expand to, because when you start thinking about what else you can do, for example, what happens if I tap it 3 times? What happens if I tap it slow twice? Does it have a cooldown? Does it have a delay? Right? Any number or infinite possibilities can arise from you reading requirements and you thinking about what other possible thing or function it can perform. So you should always think about that whenever you get your requirement, more requirements can always derive from your thought process. Very good.
So think about that. We need to think about that. How many scenario I can catch up with the requirement? Is that correct?
Can you say that again?
So we need to think about the how many scenario as a tester. We need to think about how many scenario can I catch up with the requirement. Is that correct?
Yes, it is very correct. But at the same time, and this is where it becomes complex. At the same time, as I mentioned before, you also have to be able to separate what is less priority or less severe. Okay, severity and priority, that's something that we're going to see later on in the course as well, but very simple words really that play a very important role in how you determine what you need to test first, essentially. So just as you say, we have to think of every possible scenario. However, it doesn't mean that we will be able to test every possible scenario. Do you guys get that concept?
Yes.
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 Very good. Now, defect tracking and logging. Once again, it's those test cases that will allow you to determine those defects, okay? Defect, as you heard from one of your classmates already, it is a problem or issue within the code, or it is essentially the definition of a software not working as expected, okay? And again, this doesn't only pertain to software, it can pertain to really any physical object as well, okay? It is all a defect, it is all a bug. Now, it evolves into tracking and logging. Tracking and logging are gonna be very important. So if when you find a defect, so now you have to think about, okay, I have to log this defect now. So we're gonna go into one of those tools that I was talking about earlier, Jira, Rally, HPALM, whatever it is. And I'm gonna write and I'm gonna create that defect, right? I'm gonna log that defect and I'm gonna be able to, and I'm gonna start tracking it. How will you track it? this is something that is going to have to go through a process called triage. A process called triage is really a process where you, a developer, a BA is a business analyst, gets together and talk about this defect, okay? So you track this progress. The defect itself goes through its own cycle, okay? The cycle of identifying, the following that, logging it, following that, tracking it, following that. So fixing, after fixing, gets back into retesting, and if it passes, then it moves on, right? So it's all its own process. So defects go through their own life cycle. And that brings us to this, the SDLC, or software development lifecycle. Now, software development lifecycle is really, I think I'm going to call it a process. Really, if you hear some other people, they might call it a methodology or an idea. I'm going to call it a process. The reason I want to call it a process is because from the very beginning, software development lifecycle moves in a sequential format. In other words, you can't skip a step, because if you skip a step, then you're missing out on God knows possible solutions, possible findings, right? You cannot skip a step, and whatever follows where you cannot skip a step is an actual process. Okay. And so in not being able to skip a step in this SDLC process, it's very important that we understand that in order for us to release a high quality software, we have to follow this process to the letter, to the feet, okay? From head to toe. It happens in stages and phases. This is something that I mentioned earlier. It has a process, and it also has phases, which once again we'll be seeing as we progress through the SDLC lifecycle. The SDLC lifecycle, actually. Very interesting, actually, that I say that. Now, it follows the ISO IEC 12207 global standards. And you don't have to worry about this. This is not something that you're going to be quizzed on. But it's important to know that the software development lifecycle didn't just pop out of nowhere. Just like, and you will see this eventually, Agile. The Agile process or Agile methodology also has what is called a manifesto. And in a sense, the ISO IEC is essentially a manifesto created by global standards, meaning that this is not just a single country. This is a global standard that is followed all across the globe in order to create good quality software. All right, so we're gonna go through a quick video here. I want to make sure that you guys are able to hear it. So can you guys hear that?
No video sound, like we can just see the video, but no sound there.
Well, I only played the video for a few seconds. Hold on. Can you hear the video?
Not yet.
Not yet?
Oh, no, dear.
Oh no. That poses a problem. That poses a problem. Alright, let's do something.
You could just send it in the chat and they'll be able to just watch it real quick.
That's exactly what I will do.
Or you can just share a screen.
I actually am sharing my screen. You know what? It could be because I'm sharing the, it could be because I'm just sharing the presentation itself.
You can give us the links. We can see, like, from YouTube also if you want.
I will, okay, please, I'm gonna share in the chat. Everyone, please, let me know if you're able to see it. If you're able to, get the link and access the video.
Yeah, we got it.
Okay, perfect. So what we're gonna be doing is, I'm gonna start it here and you guys can start it at the same time. So why don't you go ahead and just start it, guys?
One moment.
I will be back in about 8 minutes. Okay, so by now everybody should be completed with that video. Am I audible?
Almost done. Almost done. Just a couple of seconds.
Okay. Okay, and it is 9:04. Hopefully everybody by now is done with that video. If you're not done, I'll just ask you to pause it and so we can continue, then you can finish it later.
It's done.
Perfect. So that video is very important. In a nutshell, that video shows you the entire process of what a company goes through in the SDLC process. And if you notice something, it went step by step explaining each phase. Okay, in order for that product to actually be able to be delivered. Now he says something important somewhere mid-level in the middle of the video, and that was that based on the requirement that you previously had, you started going through the requirements and you started developing your test cases, and all of a sudden you go like, oh gosh, wait a minute, and you just come up with a new requirement on the spot because not everything was in the requirement. But how do you come to that conclusion? Because you're thinking as an end user. Okay, so as somebody mentioned before, if you remember, it goes back to you thinking as an end user and also not just taking whatever you received as the one and all. Remember, you're the end user, so you have to think out of the box. Okay. SDLC is, once again, to me, a process, can be a methodology, but it all comes down to the fact that it helps develop software. It helps develop software that is adopted by most software organizations out there in the world. It includes a comprehensive plan. It outlines how to code, how to maintain the code, okay, patch, remodel, or even improve specific software. It represents a process for enhancing the quality of software that the entire development lifecycle goes through. Each of the phase of the SDLC produces outputs, okay, as you saw in that video. And each of those outputs act as an input for the next stage. And if you remember now what I mentioned before, it's a process that you cannot skip one single step, because the previous step leads to the next. Now, so how does that work? So the requirements will translate into design, right? Now, a developer picks up the design and he writes the code. After the code is produced, it produces a build, okay? That build is what we will call, say, per se, a deployment, right, to a higher environment. Again, don't worry about the terms for now, but that code now goes live to you. Doesn't go live into for the end user, but it goes live within your team. And now you as a tester, you validate the code that was developed as per the requirement that was provided. Now, once you complete that testing, the product gets, say, shipped out. Let's just call it that way. So it's a process that goes step by step, and you cannot skip any of it. It's important that we understand this. It's important that we understand this because, once again, this is the basics to successfully doing your job every single day. Let me give you an example of what a risky and a very high rate of failure approach would be. Say you have a software that has to be developed, and a team is divided to work on a feature for the product, and they're allowed to work as they want. Now, say one of the developers decides to design first, whereas the other decides to code first. But the other one rather works on the documentation part. Now, with all three developers doing something separate and each of them working on their own thing. Now, do you think that this project will be successful?
No.
Right, it will not, because you have a developer working on the code. Another one decides to just go and look through the requirement. And another one just wants to work on design. Yes, so what says it? You have to work as a team. SDLC makes you work as a team. Okay, it's very important. Not one person is bigger than the other. This is really about a team coming together to go through a set of requirements, to analyze those requirements, to come up with the design, to implement that design, and after you implement that design, you move to proofread that design. Okay. It does make the dream work. It does. Perfect. Now we're moving into the phases of SDLC. We talked about the process, all right? And we saw how that process, how these phases here becomes that process. Now, requirement gathering and analysis. This is the very first step of SDLC. Now, if you saw the video, if you remember the video has 7 steps. This one in particular only has 6 steps. Anywhere you see, anywhere you go, you will see either from 6 to 7 steps. Why? Because sometimes the requirement gathering and analysis gets broken into two phases. But essentially, it gets done within the same step itself. But to make it more granular, it just gets broken down a little more. Now, requirement gathering and analysis is important because without the requirements, we don't know what to build. Say, say whatever you do, your boss comes to you and says, hey, listen, I want to build, say you work at McDonald's. Let's just go with that, because I'm hungry for a burger right now. So you work at McDonald's and your manager comes to you and says, hey, I'm going to use Sarwat here because it's the name that I see the most. Hey, Sarwat, so I want to work, I've actually been thinking about this new burger, right? So this is the burger that I want. And so your manager now gives you specifications. Your manager now gives you what the requirements are, and those requirements have some sort of specifications as to what it is um, that he wants, right? That he wants this new burger to look like. So now, in order for you to to start making this burger, you have to do some analysis on it. All right, how am I going to make it, right? So because he just told you he wants a new burger and he wants the burger to look like this. But now you, as the expert at making the burger, you're like, okay, fine. So how will I make this burger? Do I have to put the mayo first? Do I have to toast the bread first? Do I add lettuce to it? Right? What can make it look better? What can make it taste better? Right? It's all about requirement gathering and analysis. Okay, from requirement gathering comes analysis. Analysis produces questions. Questions produce answer, which lead now to the design. A design now providing you with how this is supposed to look. So now you know that they're gonna have two pieces of bread, right? You're gonna have the top and the bottom, and they're gonna go through a toasting process, and then you're gonna have lettuce. You have to chop up that lettuce, right? Because you were just told that you wanted lettuce, but how is the lettuce supposed to be, right? Exactly, recipe is a requirement. So this requirement now gets analyzed and how to put together a recipe. Just because you have a recipe with no instructions, you don't know how to make it, right? Because I can give you guys, here's a recipe. It has garlic, cardamom, it has cumin, it has chicken, and it also has, I don't know, heavy cream, right? But now how do you put that together? Right? So the same thing. In the design phase, we make that happen. In the design phase, we make steps. We get some specifications as to how it's supposed to look, how it's supposed to be broken down. And then comes the implementation and or coding. So now that you have all of these specifications, that the lettuce has to be chopped up, the tomatoes is gonna go sliced up, right? You're gonna have two patties, right? So now you begin your process of creating this burger, right? So you start toasting the bread. This is your coating process already. You start toasting the bread, you start chopping the lettuce, you start slicing the tomatoes, right? And then you start putting it together. Once you put it together, it goes to the tester. I would love to be a tester of burgers, mind you, but there's no such word. There's no such job out there, so I can't have it. But now the tester is looking through the burger based on the requirements. It's like, okay, based on the design and analysis, okay, it's supposed to be like this, it's supposed to have this. But then the tester sees that, okay, the mayo was supposed to go in the inside of the bread. However, the mayo is on the outside of the bread. Now we have found ourselves with a defect. So what happens with that defect? Now we're going to log that defect. We're gonna go through that. We're gonna talk with the BA and the product owner. We're gonna go through. Okay, is this how it's supposed to be? Is this what the requirement means? And then they're going to validate and say, no, actually, it's supposed to go inside of the bread, right? So now this goes back to the developer. The developer now has to fix that, right? Now the developer has to code again the bread. He has to toast that bread, and then before he puts it on before he locks it in, he has to put the mayo inside and then lock it in. So now we received that again. Now we're doing retesting. That retesting process that happens right here in the testing phase, right? Now passes. So now we move it to the deployment. Once it is deployed and it goes live, so now it is at the end user. So say, for example, AZM was waiting for the burger on the counter because that's what he ordered. So now he gets his final product, the end product, right? He's the end user and he gets his product. Right? And now that is the face of it. Maintenance, of course, I'm not sure how we can do maintenance on a burger, but just imagine that the maintenance process will always be there for any software, because in order for the software to be able to be maintained, it will continue to require maintenance. Okay. If you just deploy something, if you just if you just produce a software but you don't continue to take care of it, it's going to degrade and it's going to eventually stop working and create more and more and more defects, which is very expensive. Now, let's quickly just talk about who is where here.
Question: who's gonna maintain it, like maintenance after everything done? Like,
That's exactly where I was going.
okay.
Good question. Thank you. And exactly where I was going. So the requirement gathering and analysis, this is done by the product owner and BA. A product owner and or a business analyst. These are two separate entities, of course, two separate people. But sometimes, depending on the company, they work as the same. But the requirement gathering and analysis is basically a product owner, which knows really, gets all of the specifications, gets all the requirements from the business person, right? The big boss who wants this product, right? The client who wants the product per se. Right, so these folks now gather these requirements and they go through a series of process in order to write it down, put it together, present it to the team, and discuss it with the team. Right, so they also take care of, along with the team, they also take care of the design phase, right? Why does it matter that a lot of the whole team is involved in this process, design? Also, mostly in here as well, but mainly in the design and analysis. And that's because as you discuss the requirements, everybody thinks of different things as well. So they can always bring more ideas to the table and they can help each other out into how to develop the product. Now, the implementation and coding is done by the developer. So this right here is always the developer. And moving from the developer, obviously the testing is the tester. So you guys in this case. So when you get that code, you're going to be testing it and testing and testing. So once you, the tester, complete that, it goes now into the deployment phase. The deployment phase now is done by the DevOps team. Okay, the DevOps team can be comprised of a series of people, right? Developers, environment managers, some tester, also business folks. Okay, because this is a process. The deployment is a very important process that has to go through its own life cycle as well. Okay, to make sure that the product leaves out the door in tip-top shape. The maintenance is done sometimes by a separate team, because once your team, say, completes this software and it's deployed, okay, it's released, it goes into a maintenance phase, and that maintenance phase sometimes gets monitored by other people. Say it's already in live, so it's already being used. Now, sometimes a separate team is going to be doing the maintenance. That means that you have a maintenance team, and whenever there's an issue, that team takes care of that. At the same time, it could also go back to your team as well, because, hey, your team worked on it. Okay, so teams sometimes they break, they go their separate ways after, say, completing a project. So if your team just completes the project and that's the end of that project, sometimes your teams get broken down and you get assigned to a separate project. And so a maintenance team takes over the work. However, if your team persists, then it goes back always to your team, since you worked on it. So it becomes your maintenance. Okay. Did that answer your question?
Yes.
Awesome. Perfect. All right, so remember we talked about the infographics. So the infographics is this right here. And so just to break it down a little more, once again, and guys, I cannot stress enough how important it is that you ingrain the process of software development life cycle, because it will help you in the future. Okay, wherever you go, whatever you do, don't ever forget about basics. It's important. Number one is the planning phase, or requirement gathering, right? So you find the scope, you look for solutions, right? So your scope is the problem, and then you look for the solution. You estimate the costs, the effort, identify any risks, and the benefits that it will bring. This all happens at this is all the requirements right here. Right, you start working on the analysis and you focus on the functional requirements of it. So how is it going to come together? How is it going to work? Right? You perform a solution analysis, and then you derive the end user's needs. So what does the end user, what should the end user expect? What is it that is going to benefit them? Okay. On the design part, we're talking about elaborating the core specifications. Now, when we're talking about focus on functional requirements and perform solution analysis on step number 2, but do you see how that leads to the design phase? Once we're already past that point, we have to now go into core specifications of what the ask is. What kind of features does it need to have? The functions, how each module is going to work, right? And the flow, because it's important. As I mentioned before, with the burger example, if you go through the burger process, it has a flow, right? So the same thing with this, it's a flow. Now, what we have here, 1 second, guys, 2 seconds. Sorry about that. And so this, we're looking at the flow of it and to how to meet those requirements. Now, once we're past that point, we're going to go back to that build. That build is basically the code implementation, as we mentioned earlier. This is the developer now. So now the development begins. The coding begins. It's following the design, which we already talked about. Because the design came from first, I got this here actually. First, number 1 here, the requirement, which got broken down and analyzed, right, to a more granular level. The design now makes it even more granular, to the point where we can actually break it down in different phases. Okay, so if it's a big requirement, we cannot do it all in one single month, for example, let's say, right? So we have to break it down. So it all comes down to this. So the design now gives you the specifications as to how long it's going to take. The analysis and the design, excuse me. So now the testing begins with the developers, and there's code reviews and there's unit testings in order to make sure that the stuff is that the code is is being developed and that the major functionalities of them are working as expected, right? And then we have the tester. Once the development is done, we have the tester. So the QA team now takes the software, it tests the software, looks for errors, look for bugs or defects, and determines if the solution meets the business goals. So how does the tester determine if the solution meets the business goal? Right? This is the business right here. And then derive the end user's needs. The tester does this by being able to identify every possible test scenario that has highest priority and severity to the requirements in question. Once the tester goes through this process and tests the product and provides what is called a sign off, now it moves into the deployment phase, which moves then, so after a successful testing, of course, software gets deployed in production. Okay, so production is what we call when it goes live, but when the end user is now able to see it. So I don't know if you guys are familiar with it, but like when you're actually no, this so for most women. So when you're looking for a dress, you know that dress is going to come, but that dress is in development. You just hear that, oh, this dress is going to come in February, right? So in February 10th. So now by February 10th, now you're looking for that dress. That dress was deployed because it went through through a series of processes to make sure that it gets to your hands. So it goes through a successful testing phase. The software gets deployed into production, and the user acceptance and approval happens at the same time. So now business folks here are going through testing as well. They're looking through the major functionalities. They're looking through the major stuff that matters most to them, and everything goes well, then that's it. It's over. It gets deployed, goes live, and now it just goes into maintenance. Because after it passes through all of the stages, it enters into the maintenance phase, and the vendor here provides you support for any future upgrades and bug fixes. So if we develop that software and say we need to add a different functionality, say the dress is there, right? So now we want to add a different frill to the dress or a different button to the dress. Now the dress is going to go through the same process again. Planning, analysis, design, build, test, and deploy. The same process once again. It's all a cycle. Now, guys, we are at time here for today. There are a couple of more slides to finish this this one course, but I think we're going to touch on this slides next week, next class. Apologies, which will take place on Sunday. Sunday we will be meeting for 2 back-to-back classes with a half an hour break in between. Okay, so at that during the first half, we're going to be seeing the continuation of this, which is going to touch in the SDLC methodologies, which we mentioned in the beginning of the course. With that said, I will ask random questions at the beginning of the class on Sunday, and I will be choosing people at random. So I ask you to please make sure that you know the answer to my questions, because it's going to be very important in how we continue the class. Okay, perfect. Does anybody have any questions or anything in particular they would like to share with today's lesson?
Any homework for the Sunday? Like, you know.
Today there's no homework.
Okay, so okay, all right.
We'll get homework on Sunday though.
Oh, can we get the PowerPoint slide?
I can share the PowerPoint slide. It's going to have, however, the next couple of slides that we will be seeing in the next class.
Okay.
So, and I suppose it's okay since you will be. So how about this? I will share the PowerPoint on Sunday. Is that okay?
All right.
Okay, but if we get the recording and PowerPoint slides file, then it will be better for us to memorize all those things.
I don't disagree with your point there at all. You know what? You convinced me. Thanks for twisting my arm.
Thank you.
All right, I will send this slide over to you guys. I will cut I will be cutting the slides that we haven't talked about, and I will send up to this slide, which is the infographics. Sounds good? Sounds fair? Perfect.
Teach, I have a question. Sorry,
Yeah.
I had my hand raised. It's not related to testing, but in the build phase, that's where we do the graphic user interface work too, right?
Yep. So
Oh.
depending on the specifications of the requirements that it is, whatever it is, yeah, this is exactly where you do the implementation. The implementation essentially means that the coding is happening. So the developer now, after going through this whole process, they are putting this all into place. So be it the UI work, be it the database setup, and more often than not, this happens before. But this is in the build phase is really when everything happens, when everything gets implemented, the code gets written, and now you got a functioning application or software or piece of software.
And the architecture happens during the design phase.
The architecture can have, yes, the architecture happens during the design phase. Initial architecture also begins to happen at the planning phase as well.
Okay, gotcha. Thank you.
You're welcome. Any other questions? Perfect. Guys, you have been an amazing audience. I love chatting with you guys today. Keep in mind, the next class, once again, is going to be Sunday. We will begin promptly, so please be on time. It's going to start at 11 a.m. Awesome. Thank you all. I will see you again on Sunday.
Okay,
Bye-bye.
Thank you.
Have a good night.
You too.
Have a good night.